Hello everyone, let's continue exercise 13.1, 8th question. A die is thrown 3 times. A is the event 4 appears on the third toss. B is the event 6 and 5 appear respectively on first 2 tosses. Determine probability of A given B. Okay, so here the experiment is throwing a die 3 times. Okay, so here no need to write the sample space because there is a large number of elements in this sample space. Okay, that is there are 216 possible outcomes in this sample space. Okay, 6 into 6 into 6. Okay, 216. But here you should know what are the elements of sample space. Okay, now here we will write what are the possible outcomes of event A and event B. Okay, now let's write elements of A. A is the event 4 appears on the third toss. Okay, 4 appears on the third toss. So here the third number should be 4, right? Let's write 1, 1, 4, 1, 2, 4, etc. 1, 6, 4. Next is 2, 1, 4, 2, 2, 4, etc. 2, 6, 4, etc. 6, 1, 4, 6, 2, 4, etc. 6, 6, 4. Okay, so these are the elements of A. Next, let's write elements of B. What are the possible outcomes of B? What is the event B? 6 and 5 appear respectively on first 2 tosses. So here first number should be 5, second number should be first number should be 6 and second number should be 5. Okay, so what are the elements? 6, 5, 1, 6, 5, 2, 6, 5, 3, 6, 5, 4, 6, 5, 5, 6, 5, 6. These are the elements of event B. Okay, now we need to find probability of A given B. Okay, we know that the formula is probability of A given B is equal to probability of A intersection B divided by probability of B, right? Now let's write A intersection B. What is A intersection B? That is intersection of A and B. See here elements of A have 4 in the third place, right? See in the third place 4. So here only one element which has 4 in the third place, right? That is 6, 5, 4. So what is the common element? Common element is nothing but 6, 5, 4, right? So 6, 5, 4 is the common element of A and B. That is, there is only one element in A intersection B. Now, here to find the probability of A intersection B, here we need to know what are the number of elements of sample space, right? See, if you don't know the number of elements of sample space, directly you can write. Okay, we know that probability of A given B is equal to number of elements of A intersection B, number of elements of A intersection B divided by number of elements of B, right? That is 6. That's all. Probability of A given B is 1 by 6. Or see, if you know the number of elements of sample space, you can apply this formula. That is probability of A intersection B is equal to number of elements of A intersection B divided by number of sample space. That is equal to 1 divided by 216. Right? Next is probability of B is equal to number of elements of B divided by number of elements of sample space. That is 6 divided by 216. So here it is equal to 1 by 216 divided by 6 by 216. 216 cancelled. So answer is 1 by 6. Right? So here you can write the answer directly also. See, because we know that probability of A given B is nothing but number of A intersection B divided by number of elements of B. Right? Look at the next question. Mother, father and son line up at random for a family picture. E is the event son on one end. F is the event father in middle. Determine probability of E given F. Okay, now let's write the sample space. Before that, for our convenience, let M, F, S denote father, mother and son respectively. Okay. Now let's write the sample space. Sample space, in how many ways they can line up for family picture. See here, father, mother, son. Okay. Then mother, father, son. Right. Son, mother, father. Son, father, mother. Then father, son, mother. Mother, son, father. Over. Okay. Now there are how many elements? 1, 2, 3, 4, 5, 6. 6 elements, right? Okay. Then after that, see here, let's write the possible outcomes of E. Elements of E. E is the event sun on one end. Okay, sun on one end. So here, see, any end. Okay, so first or last. So here, possible outcomes are father, mother, son. Okay, mother, father, son. Okay, then son, mother, father. Son, father, mother. Right? So these are the possible outcomes of event E. Then possible outcomes of F are, see, father in the middle. Okay, father in the middle. So M, F, S, that is mother, father, son. Okay, son, father, mother. Mother, father, son. Son, father, mother. That's all. Right? Okay, there are two elements in the event F. Next, we have to find probability of E given F. Probability of E given F is equal to probability of E intersection F divided by probability of F. Right? Now, what is E intersection F? E intersection F. What are the common elements? Common elements are this one, right? Yes. Two elements are the common elements, right? M, F, S and S, F, M, right? So M, F, S and S. Okay. These are the elements of E intersection F. Now, what is the probability of E intersection F? That is number of elements of E intersection F, that is 2, divided by number of elements of the sample space, that is 6, is equal to 1 by 3. Okay. Next is probability of F, that is equal to number of elements of F, F 2 divided by number of elements of sample space, that is also 1 by 3. Now here probability of, that is probability of E given F is equal to 1 by 3 divided by 1 by 3, that is equal to 1. A black and red dice are rolled. Find the conditional probability of obtaining a sum greater than 9 given that the black die resulted in a 5. So here, see, the experiment is throwing two dice, black die and red die. Okay, so we know that what is the sample space? Sample space is nothing but 1, 1, 1, 2, etc., 1, 6, etc., 6, 1, 6, 2, etc., 6, 6, right? That is, there are 36 elements. So no need to write the elements, you just write number of elements in the sample space. That is 36, 6 into 6. Okay. Now, here we have to find the conditional probability of obtaining a sum greater than 9 given that another event, the black die resulted in a 5. So let's take, let E be the event getting a sum greater than 9. Okay. Next, given that another event, that is F be the event getting 5 on black die. Okay. Getting 5 on black die. Okay. Now, we have to find probability of obtaining a sum greater than 9 given that black die resulted in a 5. That is, we have to find probability of E given F. Right. So, for that, we have to write the possible outcomes of E and F. So, what are the possible outcomes of E? E is the event getting a sum greater than 9. Okay. That is 4, 6, right? Greater than 9 means starting from 10. Okay. See here maximum 12, right? See last element is 6, 6, right? So 6 plus 6, 12. So starting from 10, 10 to 12, right? Okay. So 4, 6, then 5, 6, then 6, 6. After that 5, 5, 6, 5. Okay. 6, 4. That's all, right? Okay. So these are the elements of event E, possible outcomes of event E. Next, possible outcomes of event F are, see, getting 5 on black die. And see, here you should be careful that here we are throwing the dice. First die is black die. Okay, black die is the first die and red die is the second die. Okay, so here F is the event getting 5 on black die, means 5 should be the first number. Okay, so here 5, 1, okay, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. Okay, 5 should be the first number because our event F is the event getting 5 on black die. Okay, so we throwing black die first. Okay, then after that let's find the intersection of E and F. We need to find probability of E given F, right? That is equal to, see, what is the E intersection F? E intersection F is equal to, E intersection F is 5, 5, right? 5, 5, 5, 6. Okay, 5, 5 and 5, 6. That is, there are two elements in E intersection F. Therefore, probability of E given F is 2 divided by number of elements in F, 1, 2, 3, 6, right? 6. That is 1 by 3. So, probability of E given F is 1 by 3. Okay, next one. Find the conditional probability of obtaining the sum 8, okay, given that red die resulted in a number less than 4. Okay, so here the same experiment. So number of sample space is equal to 36. Okay, and let E be the event. Let's take, let E be the event getting sum 8. Okay, getting a sum 8. Okay, then F be the event. See, given that red die resulted in a number less than 4. Here we are throwing a black die first and red die second, right? So here second number should be less than 4. Okay, second number should be less than 4. Now let's see here. So here let's take, let F be the event getting number less than 4 on red die. Okay, red die. Now here let's write what are the possible outcomes of E and F. Possible outcomes of E are, see, getting a sum 8. Okay, that is starting from, let's start from 2. Okay, or 1? No, 1 is impossible. Okay. So here 2, 6, 2, 6, then 3, 5. Okay, getting sum 8. 2, 6, 3, 5, 4, 4, then 5, 3, then 6, 2. That's all, right? Okay. So these are the elements of event E. Next, elements of F. Possible outcomes of F are getting a number less than 4 on red die. Okay. So here second number should be less than 4. Okay. So here first number, any number. Okay. 1, 1, 1, 2, 1, 3. Next 2, 1, 2, 2, 2, 3. Okay. Then 3, 1, 3, 2, 3, 3. 4, 1, 4, 2, 4, 3. 5, 1, 5, 2, 5, 3. 6, 1, 6, 2, 6, 3. That's all, right? So here 18 elements, right? 6 3s are 18. Okay. So now let's find probability of, we have to find the conditional probability of obtaining the sum 8, that is event E, right? So probability of E given that die resulted in a number less than 4, that is probability of E given F. Okay. So probability of E given F is equal to, see what is the intersection? E intersection F. E intersection F is equal to E intersection F 5 3, right? 5 3 6 2, 5 3 and 6 2, right? That's all. Okay. So two elements in E intersection F. Therefore, probability of E given F is equal to 2 divided by number of elements in F is 18, right? So 2 by 18, that is 1 by 9. A fair die is rolled. Consider events E is equal to 1 3 5, F is equal to 2 3 and G is equal to 2 3 4 5. Find probability of E given F and probability of F given E. Probability of E given F is equal to probability of E intersection F divided by probability of F, right? So here E intersection F is, let's find E intersection F. E intersection F, what is the common element? 3, right? So 3. Now probability of E intersection F, let's write it directly, okay? Probability of E given F is equal to, probability of E intersection F is number of elements in E intersection F 1 divided by number of elements in sample space. So what is the sample space? Here the experiment is a fair die is rolled, right? So a die is rolled. So what is the sample space? 1 2 3 4 5 6, right? So here number of sample space is 6 divided by probability of F. Probability of F is number of elements in F, that is 2. 2 divided by number of elements in the sample space 6, that is equal to 1 by 2. Next, let's find probability of F intersection, probability of F given E, okay? F given E, that is equal to probability of E intersection F divided by probability of E, okay? That is equal to E intersection F has only one element, so 1 by 6. Probability of E intersection F is 1 by 6 divided by probability of E. E has 3 elements, therefore probability of E is 3 by 6, that is equal to 1 by 3. Okay. Next, second one. Probability of E given G. Probability of E given G, that is equal to probability of E intersection G divided by probability of G. Now, what is E intersection G? What are the elements of E intersection G? E intersection G. What are the common elements? 3, 5, right? 3 and 5. Now, probability of E given G is equal to probability of E intersection G, that is number of elements in E intersection G 2 divided by number of elements in the sample space 6 divided by probability of G is number of elements in G, that is 4 divided by number of elements in the sample space 6. Okay, that is 2 by 4 is equal to 1 by 2. Okay, why it is 6? That is number of sample spaces, number of elements of sample space is 6 because a fair die is rolling here. Okay, experiment is only one die. Okay, rolling a die. Therefore, number of elements, that is sample space is nothing but 1, 2, 3, 4, 5, 6. There are 6 elements. Okay. Now, let's find probability of G given E. Probability of G given E. Okay. That is equal to probability of E intersection G divided by probability of E. That is equal to probability of E intersection G is number of elements in E intersection G 2 divided by number of elements in the sample space 6 divided by probability of E is number of elements in the sample space, number of elements in the set E divided by sample space, number of sample space, that is equal to 2 by 3. Next one. Third one, probability of E union F given G. So here we need to find E union F and E union F intersection G, right? So let's find E union F, that is equal to E union F. Okay, so 1, 2, 3, 5, right? So E union F is equal to 1, 2, 3, 4, 5. Sorry, 1, 2, 3, 5. And E union F intersection G, that is equal to intersection G. So what are the common elements? 2, 3, 5. Okay. Now let's find probability of E union F given G, that is equal to probability of E union F intersection G divided by probability of G, right? Now here probability of E union F intersection G is number of elements in E union F intersection G, that is 3 divided by number of sample space 6 divided by probability of G is number of elements in G 4 divided by number of sample space, that is 3 by 4. Then next we have to find probability of E intersection F given G. So let's find E intersection G. Sorry, E intersection F. E intersection F is equal to only one common element, that is 3. Okay. Next, let's find E intersection F intersection G. Okay. E intersection F intersection G, that is equal to 3, right? 3. Now let's find probability of E intersection F given G, that is equal to probability of E intersection F intersection G, that is the formula, right? Divided by probability of G, that is equal to probability of E intersection F intersection G is number of elements in E intersection F intersection G, that is 1 divided by 6 divided by probability of G, that is number of elements in G 4 divided by number of sample space, that is equal to 1 by 4. Assume that each born child is equally likely to be a boy or girl. If a family has 2 children, what is the conditional probability that both are girls? Given that first one, the youngest is a girl. Okay, first of all, let's find the first one. Okay, find the answer of first one. So here, a family has 2 children. Okay, now let's take, let capital B be the elder boy, okay, elder boy, and capital GB, elder girl, okay. Then small b be the, small b denote younger boy, and small g denote younger girl. Okay. Now what are the possibilities means sample space. The sample space is equal to both are boys. Okay. That means B small b. Okay. Capital B small b. Then next, first one boy, elder boy, then elder girl. Sorry, younger girl. Okay. Next is elder girl, then younger boy. Then elder girl, then younger girl. Okay. That's all right. B, that is both are boys. Next here, elder is boy, younger is girl. Next, these are the possibilities, okay. Elder is girl and younger is boy. Elder is girl, younger is girl. That is both are girls. So here we have to find the conditional probability of both are girls. Okay, conditional probability of both are girls given that youngest is a girl. Okay, now let's take, let E be the event, both are girls. Okay, both are girls, because we have to find the conditional probability of both are girls, right? So let E be the event, both are girls, and F be the event, youngest is a girl. Okay, youngest is a girl. Now let's write the possible outcomes of E and F. So E is equal to, what is E? E is the event, both are girls, means only one element, that is G, right? Next, F is the event, youngest is a girl. So youngest is a girl means capital B, G, and capital G, small g, right? That is boy, girl, then girl. Two elements, right? Okay. Now we have to find probability of E given F, right? That is probability of both are girls given that youngest is a girl. That is probability of E given F. That is equal to probability of E intersection F divided by probability of F. That is equal to probability of E intersection F. What is E intersection F? E intersection F has only one element, right? That is E intersection F is G, right? So only one element. So 1 divided by number of sample space 4, okay, divided by probability of F, that is 2 elements. So 2 divided by 4. That is equal to 1 by 2. So probability of, that is conditional probability of both are girls given that youngest is a girl is 1 by 2. That is probability of E given F is 1 by 2. So second one, here also we have to find the conditional probability of both are girls given that at least one is a girl. So here also let's take E be the event, both are girls, and F be the event, at least one is a girl. At least one is a girl. So let's write E, the possible outcomes of E are both are girls, right? So both are girls. So G. Okay. Next, possible outcomes of F are at least one is a girl. At least one is a girl means not this one, okay, at least. So that is greater than or equal to 1. At least 1 means greater than or equal to 1. So BG and GB, GG. It's also possible, okay, at least one girl. Now intersection E intersection F is nothing but GG, right? So E intersection F is equal to GG. Here also we have to find probability of E given F, that is equal to probability of E intersection F divided by probability of F, right? That is equal to E intersection F has only one element, therefore probability of E intersection F is 1 divided by number of S 4 divided by probability of F. F has 3 elements, therefore probability of F is 3 divided by 4. That is equal to 1 by 3. An instructor has a question bank consisting of 300 easy true or false questions, 200 difficult true or false questions, 500 easy multiple choice questions and 400 difficult multiple choice questions. If a question is selected at random from the question bank, what is the probability, that is conditional probability, that it will be an easy question given that it is a multiple choice question? So here, first of all, let's make a table of given information. See, true or false questions, easy questions 300, difficult questions 200, total 500 true or false questions are there. And multiple choice questions, easy 500 and difficult 400 questions, total 900 multiple choice questions are there. Total here easy questions 800 and difficult questions 600, total 1400 questions are there. Now here we have to find the conditional probability of getting easy question given that multiple choice question. Okay, getting multiple choice question. So let's take E be the event getting easy question. Okay, and F be the event getting multiple choice question. Multiple choice questions. Okay, now here we have to find probability of E given F. So here we cannot write the elements of E and F, possible outcomes of E and F, right? So but here we can write number of elements of F and E, right? So that is, what is total number of elements in sample space? That is 1400, because there are total 1400 questions. So 1400. And number of elements of E. E is nothing but easy questions. How many easy questions are there? 800, right? So 800. Number of F. Number of F. F is the event multiple choice questions, right? So here multiple choice questions, total 900 questions are there. Okay. Next, we have to find probability of E given F. That is equal to probability of E intersection F divided by probability of F. That is equal to, see, E intersection F. So what is E intersection F? How many questions are there? See, what is E? Easy question. And F is nothing but multiple choice questions. Okay. So that is intersection is, see, 500. It is multiple choice question and easy questions. Okay, that is the common. Okay, so here intersection of E and F is, that is number of E intersection F is 500. Okay, there are easy and multiple choice questions. 500. Okay, there are 500 easy and multiple choice questions. Okay, therefore probability of E intersection F, that is number of E intersection F is 500. Okay, that is easy question and multiple choice questions. Okay, both easy question and multiple choice questions. How many questions are there? 500. Therefore, number of E intersection F is 500. Therefore, probability of E intersection F is number of E intersection F divided by total, that is number of space. So sample space. Okay, that is 1400 divided by probability of F, number of F divided by number of sample space. 1400 cancelled. So 500 divided by 900, zeros cancelled. So 5 by 9. So here probability of E given F is 5 by 9. Given that the two numbers appearing on throwing two dice are different, find the probability of the event. The sum of numbers on the dice is 4. See, here the experiment is throwing 2 dice. Okay. Now, we know what is the sample space, right? How many elements are there in sample space? 6 into 6, 36, right? Okay. So, here number of sample space is equal to 36. What we have to find? We have to find conditional probability of the sum of numbers on the dice is 4 given that 2 numbers appearing on throwing 2 dice are different. So here let E be the event getting sum of numbers sum of the numbers is 4. Okay, getting sum of the numbers is 4. Then F be the event, see this event, the numbers appearing on throwing 2 dice are different. That is getting different numbers. Okay, then we have to find probability of E given F, right? That is probability of the sum of numbers on the dice is 4 given that numbers appearing on throwing 2 dice are different. So let's see, no need to write the possible outcomes. You just understand. See, what is E? E is getting sum of numbers is 4, right? So that one we can write. Okay, E is possible outcomes are 1, 3, right? 2, 2, 3, 1. Okay, only 3 elements. Okay, 1, 3, 2, 2, 3, 1. That's all, right? That is sum is 4. Okay. Next, what are the possible outcomes of F? See, here we know that sample space is, number of sample space is 36. See, what is the event F? Getting different numbers. Means first number and the second number should be different. Okay. So, here 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6 are not possible. Okay. Are not in this set. Okay. In the set F. Okay. So, therefore, what is the number of elements of F? Total there are 36 elements. Okay. And F is nothing but getting different numbers. So, accept these numbers. So, here 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. There are 6 numbers which has first and second number same, right? So, here number of F is equal to 30. That is 36 minus 6. Okay. So, here number of F is equal to 30. Therefore, now let's find what we have to find. Probability of E given F. Okay, probability of E given F is equal to probability of E intersection F divided by probability of F. That is, here, see, what is the elements of F? Different numbers, right? First number and second number should be different, okay, are different. But here, see, what is the intersection? 1, 3 is possible, right? So, 1, 3 is in this set, F. And 2, 2 is not possible because 2, 2 is not in the set F, okay, event F. And 3, 1 is there. So, here, yeah, E intersection F is equal to only 2 elements, that is 1, 3 and 3, 1, right? Therefore, number of elements of E intersection F is 2, right? Therefore, 2 divided by 36. So, probability of E intersection F is number of elements of E intersection F divided by number of elements of sample space. Divided by probability of F. That is, number of F is 30. So, 30 divided by 36. Right? That is equal to 2 divided by 30. That is 1 by 50. Okay. So, here probability of, that is conditional probability of the sum of numbers on the dice is 4 given that 2 numbers appearing on throwing 2 dice are different is 1 by 50. Consider the experiment throwing a die. If a multiple 3 comes up, throw the die again. Okay. And if any other number comes, toss a coin. Find the conditional probability of the event the coin shows a tail given that at least one die shows a 3. Okay. See, here the experiment is, first you will throw a die. Okay. See, if you get 3, then throw it again. Okay, if you get 3, throw it again. Next, otherwise, if you get any other number, then you toss a coin. Okay, so what is the sample space? See here, first of all, suppose you got 3. Okay, so what are the possibilities? 3. See, if you get 3, you have to throw the die again. Okay, so next, another time, second time, the possibilities are 1, 2, 3, 4, 5, 6, right? So the sample space, if you get 3, 3, 1, right? 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Okay. Suppose you are not getting 3. If you get any other number, then you have to toss a coin. Okay. That is, you have to toss a coin. So what are the possibilities? So here 1 H, 1 tail. Okay. Next 2 H, 2 tail. Okay. 3, not 3, because if you get 3, you have to throw the die again, right? Not tossing the coin. Okay. So here 4 H, 4 tail. Okay. 5 H, 5 tail. Okay. 6 H, 6 tail. So these are the possible outcomes of this experiment. Okay. That is, the experiment is, first you have to throw a die. If you get 3, then throw it again. Okay. So here the possibilities 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. So if you get any other number, then toss a coin. So what are the possibilities? 1H, if you get 1, 1H, 1T. Okay. Either 1H or 1T. So if you get 2, 2H, 2T. 4H, 3 is not possible, because if you get 3, you have to throw a die. Okay. Not tossing a coin. So 4H, 4T, 5H, 5T, 6H, 6T. These are the possible outcomes of this experiment. Okay. That is sample space. Okay. Now, here we have to find the conditional probability of the event. The coin shows a tail. Okay. So let's take, let E be the event. Coin shows a tail. And F be the event. At least one die shows a 3. See, look at carefully. See here, E is the event, coin shows a tail. See, coin shows a tail, 1T, 2T, 4T, 6T, 5T, right? And at least one die shows a 3. That is 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. That's all, right? See, when you take the E intersection F, intersection of these two sets, that is empty, right? There is no common element. Because from this experiment itself, we can understand, right? See here, coin shows a tail. See, it is at least one die shows a 3. See, if you are getting 3, no need to toss a coin, right? So here, or you can check from this. See here, E is the set, E is coin shows a tail. So only 1T, 2T, 4T, 5T, 6T are the elements of E. And F has the elements 3, 1, 3, 2, 3, 3, because F is the event, at least one die shows a 3, right? So at least 1, 3 should be there. So 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. That's all. So when we take the intersection E intersection F, we will get null set. That is, there is no common element. Therefore, here we can write E intersection F is equal to null set. That is, number of E intersection F is equal to 0. Therefore, probability of E, we have to find probability of E given F, right? E given F is equal to 0. If probability of A is equal to 1 by 2, probability of B is equal to 0, then probability of A given B is dash. Options 0, 1 by 2, not defined, 1. That's fine. Probability of A given B is equal to probability of A intersection B divided by probability of B. Right? Probability of A intersection B, it is not given. Okay. Probability of A intersection B divided by probability of B, it is given that probability of B is equal to 0. See, here we have got denominator is 0. Therefore, we can say it is not defined. Not defined. So, it is the answer. If A and B are events such that probability of A given B is equal to probability of B given A, then options A subset of B but A not equal to B. B, A equal to B. A intersection B is equal to 5, that is null set. Probability of A is equal to probability of B. Now we know that probability of A given B is equal to probability of A intersection B divided by probability of B, right? And probability of B given A is equal to probability of A intersection B divided by probability of A. So here probability of A given B is equal to probability of B given A. That implies these two are equal, right? That is probability of A intersection B divided by probability of B is equal to probability of A intersection B divided by probability of A. It is cancelled. Thus, this implies probability of A is equal to probability of B. So, D is the correct answer.